much for coming. This has been the best 8th birthday in the world.
Best 8th birthday in the world? How do you know? You only get one. How do you know it's the best?
Alexa, girl,
Don't kill my vibe.
jump in the lily pad, curb pump, say 1, 2, 3, 4. Who is it?
It's your uncle.
So you just gonna bring me a birthday gift on my birthday to my birthday party on my birthday with a birthday gift?
Happy birthday.
Gee, thanks, Uncle Quizno. Now my birthday's ruined.
We have something for you.
Hello?
And he's here! Hey, look! It's Boo Boo the Fool!
So you have your clown outfit on, like you always do.
Hey, Boo Boo. I'm having the worst 8th birthday ever. Is there anything you can do to help me?
Oh, yes! I got your special balloon!
I guess the balloon must have just gone through the ceiling into the sky. Now my 8th birthday's really ruined. What now?
I know what we can do. Here, check out number 71.
Oh, we can use differentiation and derivatives of inverse functions. On page 181, problem number 71 reads, an observer is standing 300 feet from the point at which a balloon is released. The balloon rises at a rate of 5 feet per second. How fast is the angle of elevation of the observer's line of sight increasing when the balloon is 100 feet high? In this problem, we will be using a right triangle to serve as a visible depiction of this scenario that will aid us in finding the angle of elevation. We will use the variable x to display that the balloon's height is changing as it vertically rises. The Greek letter theta represents the angle at which the height of the balloon is rising in reference to the observer's line of sight. The observer is standing 300 feet away from the point at which the balloon was released, so the leg adjacent to theta will represent 300 feet. The leg opposite to theta, x, will be equal to 100 feet because our goal is to find the angle of elevation when the balloon is 100 feet high. dx dt represents the constant rate at which the balloon rises, 5 feet per second. Our measurements on the right triangle are on the opposite and adjacent legs in reference to theta. Because we know that a tangent triangle, TOA, deals with the opposite and adjacent sides, we will be using the equation of inverse tangent to solve for the angle of elevation. U is the blob and will represent the opposite and adjacent values in reference to theta. U equals x opposite to theta over 300 feet adjacent to theta. U prime is the derivative of the blob, u, so it will equal 1 over 300. Given this information, we now can solve for the rate at which the angle of elevation changes. First, we set theta equal to the inverse tangent of the blob, x over 300. Then, we take the derivative of theta and plug into the equation of inverse tangent. The derivative of the blob, 1 over 300, goes on top, while the original u simply plugs into the u squared on the bottom. The equation is multiplied by dx dt, 5 feet per second, or the rate at which the balloon is rising. Because we are solving for the speed of the angle of elevation when the balloon is 100 feet high, we now can plug in our x value, which equals 100. Now, we multiply the fraction through by 5 feet per second, which results in 5 over 300 in the numerator. Then we square 100 over 300 in the denominator, which gives us 10,000 over 90,000. Thankfully, this reduces to 1 over 9 because my brain cells truly cannot handle all of the zeros. The numerator can also reduce to its simplest form, which is 1 over 60. Next, we condense the denominator. In order to combine these values, we must have a common denominator. Multiply 1 by a form of 1, 9 over 9. 9 over 9 plus 1 over 9 equals 10 over 9. Then, we use superfast flipping to further condense this fraction. We multiply the two values furthest from one another, 1 and 9, to result in a numerator of 9. and the two values closest to one another, 60 and 10, to generate a denominator of 600. The result is 9 over 600. Finally, we simplify this fraction by dividing the numerator and the denominator by 3. Finally, we now know that the angle of elevation of the observer's line of sight is increasing at a rate of 3 over 200 radians per second.
Gee, thanks, Aunt Quizno.
It's a piece of cake to bake a pretty cake. What?